Welcome to this comprehensive course on analyzing multimodal data using the latest advancements in large language models and Python. You'll explore the capabilities of the GPT-4 Omni model, which excels in processing diverse data types such as text, images, and audio. You'll learn how to classify text, answer questions about images, transcribe speech to text, and create natural language query interfaces over SQL databases. The course will enable you to start building your own LLM-powered applications and unlock the potential of LLMs in transforming your data analysis workflows. Immanuel Trummer teaches this course. He is an associate professor at Cornell University and has a PhD in computer science.
Large language models have recently revolutionized various areas of computer science, including text processing, code generation, and so on. Now, the newest generation of those language models, such as GPT-4 Omni, is multimodal, meaning that they can process not only text input, but also various other types of data, including images or sound files. Now, in this tutorial, I'm going to show you how you can use those large language models and Python in order to analyze various different types of data, including text processing, analyzing tabular data, analyzing images, and analyzing sound data, all from the same simple Python API. Let's get to it. We will be using OpenAI's language models in this tutorial. There are also many other providers of large language models. The interfaces tend to be quite similar, but in this tutorial we are going to focus on the OpenAI models such as GPT-4 Omni. And in order to use those models from Python, first of all, we have to install the corresponding Python library. Now here I'm going to do that as you see here. So we're going to write pip install OpenAI, and that's the name of the Python library that I will use in the following. And if I'm doing this here, then we see that the library has already been installed. Of course, in your case, it might take a little bit longer if you have not yet installed the library, but in the end, you have hopefully installed it. And as you see here, the version of the library, that is the version 1.29. Depending on when you are doing this, you might see a slightly different version if the version has changed. Typically, it doesn't make too much of a difference, but if you want to be sure that the following examples work on your machine, then you might want to install precisely the same library version, which you can do by writing, for instance, this. So now it will make sure that you have exactly the same OpenAI version. Now, after installing the library, you still need to make sure that you have an OpenAI account and that the Python library knows how to link your requests to the specific OpenAI account that you have created. Let's go to the following web address. We enter platform.openai.com, and that should lead you to this website over here. I'm gonna log in by clicking on this button here. In your case, you might have to first create an account if you're prompted to do so. After that, you can perform the steps that I'm gonna show in the following. Now, on the OpenAI platform website, let's go to the profile page, which you find over here. And in the profile page, you want to go to the user API section. And here we can create a new secret key. You can provide a name, and then you click on the Create Secret Key button. I'm not going to do that in the following because I don't want to share my key. But once you do that, you will get an access key, and you should copy that key because we will use that one in the following. Now, in order to make sure that the OpenAI library finds your secret access key, the key that you have just hopefully copied, we have to set an environment variable. And the way to do that depends a little bit on your platform. Here I'm on a Mac OS in the terminal. So the way to do that would be to write export and then the name of the environment variable that I want to set. And here you have to use the same name, OpenAI_API_key. And now we're gonna set it to the access key that you have just retrieved and generated. Here in the following, I'm just gonna set it to your key. That's of course a placeholder. And now if we print out that variable, then we should indeed see the value that we have set the variable to. And now that we have set the variable, we don't have to explicitly provide that access key in our Python code anymore, because the OpenAI library will know to retrieve that key from this environment variable. And that's all it takes. And now you are set up in order to use the OpenAI library in order to process various types of data using large language models and Python. Alright, so in the following we're going to use large language models in order to classify text documents based on whether or not the underlying sentiment is positive or negative. To make that a little bit more concrete, for instance, imagine that you have a couple of reviews that are provided as pure text, and you want to count the reviews that are positive and the reviews that are negative in order to see a little bit how you're doing. That's a problem also called sentiment classification. So basically our input is a text document and the output should be the underlying sentiment, whether it's a positive review or a negative review. And in the following, we're going to implement that in Python using the GPT-4 Omni model. So here we are using OpenAI models, and we have already installed the OpenAI Python library. So the first thing that I need to do in order to use OpenAI models from Python, that's to import the corresponding library. So that's right, import the OpenAI, all right? Now, the second thing that you typically want to do when using the OpenAI models is to create a client object. The client object is how you interact with all of those OpenAI models. So here we're just going to write client equals to OpenAI dot OpenAI. All right, so this creates the client object that we will use to interact with the language models. Here we have already specified the OpenAI access key in an environment variable. If we had not done that, then we could provide the access key here as a parameter when creating this client object. But here we don't need to do that. All right, so now we have our client object. Let's start creating a code that uses OpenAI's language models. All right. Just making sure that the following code is only executed if we execute directly this Python file. All right. So in the first version, I'm just going to assume that users provide the review to classify as an input parameter. In order to process input parameters, I'm going to use the standard library argparse. All right. So here we're going to parse the arguments that users provide on the command line. And here let's first of all create a parser. All right, so we're creating the argument parser object. And now I'm adding arguments that we want to parse from the command line. And so here it's simply going to be a text that we want to classify based on whether it's positive or negative sentiment. So the type of this input argument is a string. And here I'm adding a little help string that will be shown to users if they don't provide this input parameter. And here that's simply a text to classify. All right, so here I'm going to parse the input arguments. All right, so now this args object contains the values for those input parameters. Now, whenever you use a language model, you have to provide it with a prompt as input. The prompt essentially describes the task that we want the language model to solve. So in our case, the task is to classify the input text in terms of whether or not the underlying sentiment is positive. All right, so let me introduce a new function here in order to create the prompts that we want to send to the language model. All right, so here the prompt will essentially consist of three parts. First of all, we have to provide the input text to the language model. Then we have to provide the language model with some instructions on what it should do with the input text. And then finally, in order to make it easier for us to parse the answers by the language model, we should provide some formatting instructions to the language model with regards to the answer format. All right, so I'm going to call this function create prompt. And since the text to classify should be included in a prompt, we need to specify that as a parameter. I'm going to write a little bit of documentation here. So the purpose of this function is to create the input prompt for the language model. All right, and it takes one argument, one parameter, which is the text, and that is the text to classify. And what it returns is a prompt for text classification. All right, good. So first of all, we want to provide some instructions, or rather a question in this case, to the language model. And here those instructions that could be, for instance, to see whether the following holds. Is the underlying sentiment positive or negative? All right, and there are a couple of different ways to answer to this question. Maybe it could be an entire sentence as answer. Maybe the language model writes back the underlying sentiment is positive. Or maybe the language model decides to abbreviate positive by P and negative by N. So in order to make it easier for us to parse the answers, we probably want to add a little bit of formatting instructions for the language model. And so here I'm simply gonna provide the possible answer options. And here that is gonna be positive or negative. So the answer of the language model should be one of those two. Now let me put all of this together into a prompt. So here we're gonna first of all put the input text to classify. And then in the next line, we're gonna put the instructions. And then in the next line, I'm gonna add the formatting related instructions. And I'm gonna encourage the language model to now come up with an answer. I'm gonna add this. All right, so this is a concise prompt which describes to the language model what we wanted to do in natural language, of course, and it contains all relevant context, namely the formatting instructions for the output, as well as the input text that we want to classify. All right, so here I have a way of creating a prompt. So I could, for instance, use this in order to create a corresponding prompt. So here I'm going to use the create prompt function, and we're going to use that on the input text that users have provided as an argument on the command line. All right, and now the next thing that I want to do is to call the language model with that prompt. All right, so now we can generate prompts. The next step is to send those prompts to a language model in order to get a corresponding reply. So in the following, I'm going to introduce the call LLM for large language model function. And this function takes as input the prompt which we want to send to the language model. Now here I'm going to write a little bit of documentation. So the goal of this function is to call the large language model with the input prompt in order to get a reply. All right, the function takes one single parameter as input, which is the prompt that we want to send to the language model. And as a result, the function returns the answer that it obtains from the language model. All right. Okay. Now, in order to call the large language model, I'm going to use the client object that we have introduced before. And here, let me remind you, this is where we have created the client object, which we need in order to interact with those OpenAI models. Now, in the following, I'm going to use a specific model by OpenAI, which is the OpenAI GPT-4 Omni model. And that happens to be the most recently released model by OpenAI at this point. The particularity of that model is that it processes not only text as input, but various other types of data, such as images, which we will explore later. For the moment, we're just sending text to the model, but we could be sending a mix of different data types as well. Now, the GPT-4 Omni model is one of the so-called chat models. And those chat models have been generally optimized for scenarios where we have multi-step interactions with the user, which is what you would have, for instance, when using those models in the web interface. All right? And that means that as input for those models, we generally specify a sequence of messages which can be generated either by the user or by the model in previous dialogue steps. Now, in this case, that is kind of overkill because we actually only want to send one single prompt to the language model and get back one answer by the language model. But since we want to use one of the chat models, we generally have to specify a sequence of prior messages in the dialogue as input in order to get an answer. And that's what we are going to do in the following. So here I'm going to specify prior messages as a list. And each of those messages in turn is defined by a Python dictionary. In this case, I only have one single message, and I'm going to specify two attributes for that message. First of all, I'm going to specify the content attribute, and here I just want to send my prompt to the language model. So that content is just going to be the prompt that we have specified as input parameter. And now, as I mentioned previously, those messages, they could be taken from a multi-step dialogue with the user, which would mean that some of those messages have been submitted by users, whereas other messages have been generated by the language model in prior dialogue steps. So in order to distinguish the source of those messages we generated, then I'm going to specify the role attribute, and the role attribute can take one of several pre-specified values, and in this case I'm just gonna specify the user value, meaning that this message has been generated by the user. I could also have specified assistant, which means that the message has been generated previously by the large language model. And then there is a third option, which is to specify system, and system messages, they're typically used at the very beginning of one of those message sequences in order to specify the general behavior of the model. So if you want to behave the model in a certain way, then you can write those instructions into a message with a system role and put that typically at the very beginning of the dialogue. But in this case, we don't even need that. We actually only want to submit one single message which contains this prompt that we have generated previously. Now, in order to call the model, I'm going to use the client object. And here specifically, I'm going to use the chat category because I want to call one of the chat models. Most of the recently released models by OpenAI are actually chat models, all right? And what I want this model to do is to complete my input messages by generating an answer. So that is why here I'm going to deal with the completions endpoint, and here I'm gonna invoke the create functionality, which enables me to create an answer from this chat model. Okay, so here first of all, of course, I need to specify the messages as input, which here contains only one single message, which is the input prompt, and then I have to specify which model I want to process this input, and here I want to use the GPT-4o model, which stands for GPT-4 Omni model, the most recently released model. All right, and now this invocation should generate a response object, all right? And this response object contains quite a lot of information. It contains the message that I'm actually interested in, and it also contains additional metadata. Now I'm gonna, for the moment, return the entire response object such that we can have a look at it. And then later we're gonna extract just the part of the response object that we actually care about in a scenario, which is the answer generated by the language model. All right. So now here I have generated the prompt. So now I want to generate an answer. And for that, I'm going to use the call LLM function with the prompt as input. And then I'm going to print that answer. All right. So now I'm going to run this, code. And here I'm going to specify the command line arguments. I'm going to run that directly from Eclipse, but you could, of course, also run the code from the command line. And here I have specified a very simple example. So let's say I want to classify the input text. The movie was great. So probably there should be a positive sentiment. If that was a review for the movie, then it would certainly be a positive review. So now let's see whether the large language model is also able to figure that out. All right, so now we have the entire answer generated by the language model. So I'm gonna make that more readable by inserting line breaks. And you see this is an object of type chat completion. There's some IDs associated with the job. And then you see here a couple of choices. So here actually we only really have a single choice, but it is possible to configure those language models in a way that they generate multiple answer options. We are not doing that in this case, so we only have one single option. Now here, this is the choice that you see here. And there's a couple of fields that provide you with additional information about the invocation. For instance, here we have the finish reason, which is stop. Other options could be, for instance, if you have specified a length limit on the reply by the language model, then you might see that the language model has terminated due to reaching the limit on the answer length. But here the finish reason is stop, and that means that the language model has generated an answer that it deems to be complete. It was not restricted by any limits on the output length. All right, so here the most interesting content here is probably this chat completion message object. And this describes basically the next message in this sequence of messages that I have provided as input. And you see again that we have not only the content, but also the role attribute. And here the role is now set to assistant, which means that this message clearly was generated by the large language model. And here the content of this message is actually very concise. It simply states that the input text is positive. And this is actually great because first of all, that is the correct result. And also this is the correct format in which I want my answers, because I specified to the language model that possible answer options are either positive or negative. All right. Here you see a couple of other metadata fields. I'm not gonna discuss them in too much detail, except for perhaps this one here. So here you see some usage statistics. And what you see here is, first of all, the completion tokens, which is only one. So that measures the length of the answer in tokens. And those tokens, that is the atomic unit at which the language model represents text internally. And you should actually care about the number of tokens, because the number of tokens decides how much money you have to pay in order to process your data. You pay for the amount of data that the model generates, for the number of tokens that the model generates, and you also pay for the number of tokens that the model is reading, which you have here, the prompt tokens, that is the length of the input measured as the number of tokens. So in total here, since I had 29 input tokens and 1 output token. I have processed 30 tokens in total. Now I have returned the entire response object. Ultimately, I mainly care about the actual answer content. So here I can refine this call LLM function in order to already extract just a part of the response that we are most interested in, and that would be here the completions.choices field. And since we might have multiple choices, but in our case we only have a single choice, we only care about the first and only element within the corresponding list. And now from there we extract the corresponding message. All right, and from that message we extract the content, and this is what we return as an answer. So if I now run this code again, then it should give me a more concise output. So here it only returns the actual result that the large language model has generated. All right, so now we are successfully classifying one single review. Let's see how we can expand that into code that processes an entire CSV file containing multiple reviews. So in order to do that, first of all, I'm going to import the pandas library because it makes it fairly easy to handle CSV files. All right, and now here, instead of asking users to specify text for one single review to classify directly as part of the input, I'm rather gonna ask them to specify a path to the input file. So here I'm gonna change that to a path, still of type string, and now the help is gonna be, this is the path to the input file. All right. Now, in order to easily apply all the code that I have written here to a column in a pandas data frame, which is what I'm gonna load this CSV input to. I'm gonna specify a new function which handles the entire classification. So here I'm just gonna call that function classify. The input is gonna be the text that should be classified. And here I'm going to write a little bit of documentation. So here this is going to classify the input text using the input text as argument. This is the text to classify. And the output of that function is going to be the class label, which is either positive or negative. All right, and in here I'm basically gonna do the same thing as I did previously. First of all, we're gonna generate a prompt here, this time referring to the input text, and then we're gonna use the language model in order to generate the corresponding answer, and that is gonna be the final result of this function. All right, so now we have packed the whole classification into one function. It will make it easier to apply this function to all the entries in one column of the input document. So now that we have specified the path to the input document here by the user, we can use the pandas.read CSV function on the input path in order to read the corresponding data frame. So here I'm gonna read the input data into this data frame variable. All right, so I will assume that in the input data, the text that I want to classify is contained in a column named text. So I can access that column as you see here. And now I can simply apply the function that I have introduced previously to each entry in that column using pandas apply function here. And here we're going to apply the classify function over here, and we're going to store the result in a newly created class column. And finally, we're going to print out the data frame using the print function, and it will contain the original columns as well as the newly created class column, which contains the results generated by the language model. All right, so now I'm gonna try this out, and I have already prepared some sample data in this data subfolder. It is a CSV file called reviews.csv, and that CSV file contains just a couple of reviews from the International Movie Database. So here I'm gonna specify the path to this input file. Now I'm gonna run the code again. All right, so here finally we see the output. So here we see extracts from the review, and we see the class, the output class over here. So here from the snippets that I can recognize from the reviews, for instance, here, low budget but still creepy enough to hold your attention, I assume. So that sounds like indeed a positive review. And here, just to save you the $3 or whatever it costs here, that is probably going to be a negative review indeed. So here I see that in most cases the model has generated the correct output format. So here it's either negative or it's positive. In a few cases, the model has actually added a little bit of text at the beginning. So here, for instance, it has clarified that it's about to generate the answer to my question, which I don't really want it to do here. So there are a couple of ways in which I could try to reformulate the input prompt in order to make it more reliable. There's also a couple of options to configure the model in order to make sure that it can essentially only generate the two tokens that are associated with positive or negative. But for the moment, I'm not gonna do that. This is a very simple implementation, but it seems to do well in most cases, classifying those reviews. The newest generation of large language models is multimodal, which means that it can analyze various different types of data. In the following, I'm going to show you how we can analyze not only text input, but also images. We're going to build a simple version of a question answering system, which can answer arbitrary questions in natural language about input images. So to this program, we're going to provide as inputs the URL of an image together with a question that we want to answer about that image, and then we're going to use a GPT-4 Omni, the most recently released language model by OpenAI, in order to answer questions about those images. All right, so let's get started here. First of all, I'm gonna import the argparse library in order to process the input arguments which users can specify on the command line when invoking the code here. We're gonna protect the following code and make sure that it's only invoked if we invoke this file directly. And now we are gonna create a parser for the command line arguments here. And we're going to add some arguments. So here, as I have discussed previously, we want to answer questions about images. We have two input parameters. First of all, we have the URL of an image, and then we have the question that we want the language model to answer about that image. So first of all, I'm going to add the following argument. It's image URL of type string, and here the help is simply that this is the URL of an image, and also I'm going to add another parameter which is a question, also of type string, and here the help is simply question about image. All right. Now we're gonna parse the arguments from the command line. They will be stored in this args object. All right, and that is all the input that we need for the moment. All right. Now, in order to perform the actual analysis, I'm going to introduce a dedicated function that is the analyze image function. And as input, the function obtains, of course, the URL of the image that we want to analyze, followed by the question about the image that we want the language model to answer. All right. Now here I write a little bit of documentation. So this should answer questions about the input image, and it has those two aforementioned parameters, the image URL, that's the URL of the image that we want to analyze, and then we also have the question that we want to obtain an answer for. And what the function should ultimately return, that is the answer to the input question, which is generated considering the image that I have referred to. And we will use the language model, more precisely OpenAI's GPT-4 Omni model, in order to answer the question about the picture. All right. All right. Now, in the body of this function, of course, I have to invoke the language model. And if you remember the previous code, we have to do the same things in order to use language models. First of all, of course, we have to import the OpenAI library, because that's the library that we generally use in order to interact with those language models by OpenAI. Now, the other thing that I have to do after importing that library is I have to create this client object, which I will use directly in order to interact with those language models. All right, and since I assume that the access key for your OpenAI account is already provided in one of the environment variables, I don't even need to specify any input parameters. It's enough to write this here, and that will give me the client object that I need in order to interact with the language models. All right. Now, in the body of that function, I'm going to use the language model in order to answer the question about the image. Now, we have already seen how to invoke models such as GPT-4 Omni, which I will use in the following. That's the latest model released by OpenAI, and it supports multimodal inputs, which I will need in this case. Now, I will use the client object in order to invoke the model as we have done previously. So here I'm gonna refer to the subcategory chat, because GPT-4 Omni is one of the chat models. And then I'm gonna use the completions endpoint. I'm gonna create a new request. Now in this request, first of all, I have to specify which model I want to invoke in order to answer my request. And in this case, we're gonna use the GPT-4 Omni model. So the ID, that is GPT minus 40. And of course I have to specify the input that I want to send to that model. And GPT-4 Omni is one of the so-called chat models, which means that it generally expects a sequence of messages as input, because it has been designed for scenarios where there has been potentially a back and forth interaction, a dialogue between the user and a model previously. Then it wants to generate the next message in that interaction. Now in this case, that is overkill, because I only want to provide one single message as input, which contains the image URL and the question that I want to that I want the model to answer. But nevertheless, because it is a chat model, I generally have to specify a sequence of messages as input. So here I have to set the messages parameter, and I'm going to set it to local variable messages that I'm about to define. And so here messages, that is generally a list of messages, but in this case I only need one single message, for which I again introduce a local variable that I am about to define. Now, Previously, we have used messages that contain text content. In this case, it's gonna be a little bit more sophisticated because our message actually contains two parts: the question that I want to answer and the URL that the question refers to. The URL contains an image about which I want to answer a question. Now, generally messages, they are represented as Python dictionaries. First of all, I have to define where the message is coming from, who generated the message. Now, in this case, there's only one message, and that message has been generated by the user. That is why I'm setting the role attribute to the value user. It also could have been assistant if it had been generated previously by the model within the same dialog, or it could have been system if I wanted to define generic behavior of the model at the beginning of the exchange. Now, in this case, it's a message that originates from the user, and besides the source of the message, I also have to define, of course, the content of the message. Now, previously we had simple content. In this case, we have content that consists of multiple components actually, and those components also have different data types. I have text for the question, and I have an image. So because of that, now the content is actually a list with multiple components, and each of those components is in turn defined again as a Python dictionary. Now, I have components of different data types. So first of all, I have to tell the model which data type I'm providing here. So there's a type attribute, and for the first component, I'm setting that type to text. And here the text, that is simply the question that I want to answer. Now the second component here, that is the image that I want the question to refer to. And now this is a different type. This is a type image URL. And here the image URL is again defined as a Python dictionary. So here, in order to keep things simple, I'm only gonna specify the actual URL. I could specify more parameters. For instance, I could specify whether the model should analyze the picture at high precision or low precision. High precision is a little bit more expensive, but can sometimes provide you with better results. But in order to keep things simple, I'm just gonna keep it to the basics. I'm just gonna specify the URL to the image that I want to analyze here. All right. Now this is the message that I'm providing as input to the model. It consists of two components. The content, the first one is the text question, and the second one is the image reference. I'm gonna put that message into the message history, and then I'm gonna provide the model with those messages as input. Now, once I invoke this completion functionality, I will get a reply object, and as before, this reply object will contain more information than I need in this specific case. It will contain lots of metadata. What I actually want is to access just the answer from that reply object, and I can access that answer as I do in the following. So first of all, I might configure the model in order to generate multiple different answer options. In this case, I'm using the model with default options, so it will only generate one single choice for the completion options, and that means I'm accessing the first element of those choices. And for that first completion choice, I'm accessing the message attribute, and within the message, I'm actually interested in the content of that message, and that is what I want to return as the result of this function over here. So I have defined the function, so the only thing I now need to do is to invoke the function using the input parameters that the user has provided on the command line. They are contained in this args object. So I have here the image URL, and I also have here the question that I want to answer. And the function will return an answer object to me, and I'm simply gonna print that one out. So that should be an answer string. So now we're gonna give it a try. I'm gonna invoke this QA code that I have just written. And here as input parameters, I have specified the URL of an image. I'm going to show you the image in the following. You see that it only shows a couple of apples on a tree. All right. And the question that I have here is simply, what is this? So I basically want a description of the image by the language model. Let's see whether that works. All right. So here, the description of the picture generated by the GPT-4 Omni model is, this is a photo of red apples growing on an apple tree. And if you compare the description again with the picture, you see that it is actually quite accurate. Now in the following, I'm going to make things a little bit more exciting by asking the model not to answer questions about one single image, but I'm going to provide 2 images as input, and then I can ask the model, for instance, to compare those images to figure out differences and common points and so on. So now I'm going to change this code by adding one more input parameter first of all. So instead of providing the model with one single image URL, I'm going to provide 2 URLs. So here, that is the first image URL. All right. And now image URL 2, that is the second image URL that I want to provide as input. And now the question refers to both of those images. All right, so now I have changed the input parameters, but of course I also need to change this function over here. Right now the analyze image function only takes one single image as input. Instead I want to make it take 2 images as input. So here I'm gonna add one more parameter. So here we're going to have 2 image URLs as parameter, and here I'm going to update the documentation as well before I update the body in the end. So here answer a question about 2 input images. All right, and now the arguments have also changed. So here that is the URL of the first image to analyze, and the next parameter, that is the URL of the second image to analyze. All right. All right. So now in the following, I'm going to update the body of that function. So here we have to change the message, because right now the message only contains one single image, but instead of that, I want to show that the model can also handle messages that contain multiple images as input. So here, first of all, I have to change the reference to the first input image. And also I have to add one more component to the content of that message, because now we have a second image URL. It is also of type image URL here, like the first image. And here I'm specifying the details of that image URL. And in order to keep things simple, I'm simply specifying the URL without any other parameters. And all the rest actually can stay the way it is. So I'm gonna put that message into a list, and then I'm providing the GPT-4 Omni model with that message as input. And then I'm gonna just extract the answer string from the reply object that the model generates. All right, and here in the main function, I'm invoking the analyze image function. I do have, however, to change the input parameters. So here the image URL is replaced by 2 image URLs. So here, simply gonna add that. And I'm also adding, and I also have still the question that I want to answer. And finally, I'm gonna print out the answer that I obtained from the model. Now, first of all, in order to try this out, I need a second picture. And previously we have used this picture of apples growing on a tree. The model was able to describe this image quite accurately. The following, I'm going to add a second picture over here. So here that is an image of oranges. They're not on a tree. I'm going to copy the corresponding URL. And now I'm going to provide the code with that second URL as input. So here I'm going to add the second URL as the second input parameter, and I'm going to ask a question that refers to both pictures at the same time. I'm actually going to instruct the model to compare the two images. Let's see what it does. All right, and here it generates actually a longer answer with a detailed comparison between those two images. The first one showing apples, the second one showing oranges. And here, for instance, it correctly points out that we are dealing with different fruits, apples in the first one and oranges in the second one. It also discusses other aspects, like, for instance, the colors, which are clearly different. And here it even focuses on the leaves that are associated with those two input pictures. It captures the fact that the apples are depicted on the tree, whereas the orange is not really on a tree. It compares the images in terms of style. For instance, the first one looks like a photograph, whereas the second one looks more like an illustration or drawing. It focuses on the background too, and it points out that in the second picture the background is white, whereas in the first picture we have something like an orchard. And finally it compares them in terms of context. So it was actually able to automatically identify some pretty reasonable categories that it can use in order to compare those images. And for each of those categories, it was able to generate a detailed comparison between those two pictures. So that shows you that the GPT-4 Omni model is indeed able to handle prompts that contain multiple different components of different data types quite reliably. All right, so now it's time to analyze a different type of data. We're going to focus on audio data in the following. And one very common task that you want to do if you have audio data, that is to transcribe it, for instance, in order to generate subtitles for a video. So in the following, we're gonna take audio files on disk, and we're gonna extract the text from those files by transcribing them. Now, we have mostly used OpenAI's GPT-4 Omni model, and that is a multimodal model, and in principle it can support audio data, but at the time at which I'm recording this tutorial, that functionality is not yet available via the Python API. It's probably gonna come soon, but for the moment we're actually gonna use a different OpenAI model, which is the Whisper model, and this model has been specifically trained for transcribing audio data to text, and that is the functionality that we will be using in the following. All right, so in the following, I'm going to create a code that takes as input parameter on the command line the path of an audio file. Can be a variety of different formats that are supported by the Whisper model, and then it prints out a text transcription of that audio file. So here I'm first of all gonna import the argparse library in order to enable me to parse those arguments from the command line. All right, and now here we are making sure that this is only executed if we call this code directly. Now I'm creating the parser, the command line parser over here, and I'm gonna add one single argument, which is the reference to the audio file that I want to transcribe. So here I'm gonna add the audio path argument. It's of a type string, and the corresponding help is a path to audio file. All right, here I'm gonna parse the command line arguments. All right, and they will be stored in this args object. All right, And now what I'm going to do in the following is to define a function that transcribes an audio file. So here I'm going to call that transcribe audio, and the only input parameter will be the path to the audio file that I want to transcribe. Now I'm going to add a little bit of documentation here. I'm going to say that this function transcribes audio files and returns text. There's only one single input parameter, the audio path, and that is the path to a file to transcribe. And what it returns is the transcription. Now in the body of that function, I'm first of all going to open the audio file. So I'm going to write with open, and here is the audio path, and I'm going to open the file in a binary mode. And now I'm gonna use functionality of the OpenAI library again. So first of all, I have to import the OpenAI library, and then as always I have to create this client object, which I will use in order to invoke functionality from the OpenAI models. So here I'm gonna create the client object, and now I can use this client object here in order to invoke functionality. And what I'm going to do here is to go for the audio category, and here there is the transcriptions endpoint, and here I'm going to create a corresponding request. Now here in that request, I first of all have to specify the ID of the OpenAI model that I want to use. And now, different from the previous sections, I'm not going to use the OpenAI GPT-4 Omni model. In principle, that model supports sound, but as I have discussed quickly previously, that's not yet enabled via the API at this point. So that's why I'm going to go for a different model. And the model that I'm going to go for is the Whisper model by OpenAI, which is a model that is specialized in transcribing audio. All right, so I'm going to set the model ID to the Whisper 1 model. And the other thing that I need to provide as input is, of course, the file that I actually want to transcribe. And so here I'm going to set the file parameter to the audio file over here. All right, now that is gonna generate a reply, and for the moment I can just return the entire reply. Later I'm gonna access only part of the reply that I really care about. And now that I have defined this function, I can invoke it in the main part here. I'm gonna write reply equals transcribe audio, and as input parameter I'm gonna specify the audio path which users have provided as input to the code on the command line. All right, so for the moment I'm just gonna print this reply, and now I'm gonna try this out using an example audio file. Now the example audio file is just a quick quote from a very famous novel, The Alchemist by Paulo Coelho. I'm gonna listen to this audio file in the following.
2 years ago, right here on this spot, I had a recurrent dream too.
2 years ago, right at this spot, I had a recurring dream too. So we can easily understand the text that is contained in this audio file. Now let's see whether the model of OpenAI can do the same thing. So now let's try this out. I have created a configuration to run this code that I have just written. And you might remember that we only need one single input parameter, which is the path to the audio file that we want to transcribe. And in this case, the audio file is located in the data directory, and the name is simply quote from the alchemist.mp3. So that is one of several audio file formats that are supported by this approach. So now I'm gonna run this code, and indeed, you see the transcription here. 2 years ago, right here on this spot, I had a recurrent dream 2. So that is actually the correct transcription, so the approach has worked. And if I only want to get the text from this transcription object, I can simply access the text attribute, and if I run the whole thing again, then now I am getting directly the text of the transcription, and as you see here, it is indeed generating the correct output. So as you see here, analyzing audio data using the OpenAI models is actually very simple. Again, I have used the Whisper model, but going forward, you can probably do the same thing with OpenAI's GPT-4 Omni model too. Now in the following, we're going to use large language models in order to analyze large tabular data, like large databases with relational tables. So far, we have been using language models in order to analyze data directly. So for instance, when analyzing text, we have provided a language model with the text that we want to analyze together with the analysis instructions. For instance, telling the language model that we want to classify text in terms of the sentiment. Or when looking at images, we have provided a language model with direct access to those images together with text instructions about what we want the language model to do with those images. Now, the problem with large data tables is that language models are maybe not ideally suited in order to analyze tabular data directly. Also, if you have a large table, then it's actually going to be very expensive to make the language model read all of that data, because for providers like OpenAI, you pay for the amount of tokens that you are processing. So if you are processing a large table, then you have to pay a lot of money. So in the following, when analyzing tabular data, we actually want to avoid that. So instead of using the large language model directly in order to analyze data, we are going to use the large language model in order to translate questions about the data into queries in the SQL language, which is the structured query language. And then we're going to use specialized tools. More precisely, we're going to use relational database management systems, which can very, very efficiently process those SQL queries on such tabular data. But still, we need the language model in order to translate the questions formulated in natural language into formal queries in SQL. And this is what we're going to do in the following. So we're going to start by making sure that this is only invoked if we invoke the corresponding code directly. And for the moment, I'm just going to create a simple version of this natural language query interface, which simply takes a question natural language and then it translates it into a corresponding SQL query based on a description of the structure of that data. So first of all, I'm gonna parse input parameters, and for that I'm gonna use again the argparse library. Now here I'm gonna create a parser object, the argument parser. I now I'm gonna add one single argument, which is gonna be a question of type a string, and the help is gonna be this is the question that we want to translate into an SQL query. Here I'm gonna parse the corresponding arguments. All right, so here users provide us input a question in natural language, and now the goal of this code for the moment is to simply translate this question into a corresponding SQL query. Now, in order to translate questions to queries, I first of all need to create corresponding prompts. So I'm going to introduce a function create prompt, which will create a prompt to translate questions into SQL queries. Now it takes one input parameter, which is the question to translate. I'm going to add a little bit of documentation here. So here this function creates a prompt for text to SQL translation, because this is what we want to do, right? We have a question formulated as a natural language text, and then we want to translate this question into a semantically equivalent SQL query. All right. So here the argument, that is the question to translate, and what it returns is an SQL query that translates the input question. All right. Now the prompt that I'm gonna create here will contain multiple parts. So here I'm gonna introduce a list called parts, which I will combine into one single string at the end of the function. Now here I'm gonna first of all include a description of the structure of the data, because as the name SQL structured query language indicates, here we are dealing with structured data, meaning that we are dealing with data tables that have clearly specified column types and potentially additional constraints. And of course the tables and the columns of those tables, they are associated with specific names that represent their semantics. So in order to translate questions into corresponding SQL queries, I definitely need to know something about the structure of that data, such as the names of tables and the names of their columns and perhaps the column types. All right. And that is why the prompt should contain as a part a description of the structure of the database. And that's what I'm gonna add in the following. So first of all, I'm gonna tell the language model that now I'm gonna describe the structure of the database. And for the moment, I'm actually assume that this whole code is specific to one specific database. And let's say that this database contains a table with information about customers. So probably we want to call that table the customers table, and we want the table to have a couple of columns, for instance, with a customer ID, with a customer name, and maybe the city in which those customers live in. All right. Now in the following, I'm going to show to the language model simply the command in SQL that I would use in order to create the table structure, which is the create table command, and it is followed by the name of the table and then a list of the columns that appear in this table with column names and column types. So here in this very simple example, I'm simply going to write a create table customers with a column customer ID of type int, and a column customer name of type text, and a column city of type text as well. All right. So here this creates the table, and if the language model knows the structure of the table by looking at the create table command, then it can hopefully translate my questions about the customer data into semantically equivalent SQL queries. And this is what I'm going to ask the model to do in the next part of that prompt. So here I'm going to append a text snippet where I'm asking the model translate this question to SQL. Now of course I have to provide it with that question, and here I'm simply going to add the input question that I want to translate. So now I have a list with different parts that should definitely come into this prompt. In the end, I'm just going to combine all of this into one single text that I'm going to send to the language model, for instance, by just adding new lines between those different parts. So I'm joining them, joining parts separated by new lines, and that's what I'm going to return as the result of that function. Now this is what I want to send to the large language model. Following, I'm going to invoke that large language model. I'm going to use the GPT-4 Omni model again. And I'm going to create a function which calls the language model and returns the answer that the language model generates. So here I'm going to create the call large language model a function. The input is going to be a prompt, and the output is going to be the answer that the language model generates. So let me add a little bit of documentation. So here this returns the answer generated by the large language model. All right, and the input, that is first of all the prompt. That is what I'm sending to the language model, and what it returns is the answer generated by the large language model. All right. And now we have already seen that in order to call large language models, the first thing that I'm generally doing is to import the OpenAI library. All right. And the second thing that I'm doing is to create a client object that I will use in order to interact with those large language models. So here I'm creating a client object. And again, as before, I assume that the access key for your OpenAI account has already been specified in an environment variable, so I don't need to do that when creating the client object. And now I can use the client object in order to invoke the large language model. So in the following, I'm simply gonna invoke the completion function again. So here I'm gonna use the client. I'm considering the chat category of models because the model that I want to use, the OpenAI GPT-4 Omni model, is one of those chat models. So I'm going to go to the chat category, and what I want to do is to use that for completing my input, and gonna create a new request here where I first of all specify the model name, and that is gonna be GPT-4 Omni. Okay, and since GPT-4 Omni is a chat model, as I have discussed previously, it is optimized for an exchange between user and model. That is why generally as input I'm going to specify a list of messages, which in this case only contains one single element. So here I'm going to define the messages variable with one single element, and that message is defined as a Python dictionary. I need to specify the role attribute, which I'm going to set to user, because this input message has been generated by the user, so to speak. And the content of that message is simply going to be the input prompt, which is essentially this text string that I want to send to the model. So previously we have considered prompts, input messages that contain multiple parts, maybe multiple images even, and some text. In this case, it's actually a simpler input. It's just going to be a text input. Now I'm going to use those messages as input to the language model in my request, and sending that request should generate a reply. From that reply, I'm again going to extract the actual answer text. Of course, the reply object contains additional metadata that I'm not really interested in. So here I'm again going to access the choices field, and I'm going to access the first element in those completion choices, because here I'm only generating one single completion. And from that element, I'm accessing the message attribute, and from the message, I'm accessing the content attribute, and that's what I'm going to return as the answer generated by the language model. So now I have a function for generating prompts. I'm going to invoke that function, and here the only input that I need to specify is the question that I want to translate into a corresponding SQL query, and that question is specified as a command line argument by user. So it's stored in this args object. I'm gonna access it here, and that gives me a prompt which, if I send that as input to the large language model, it should instruct the language model to translate the input question to a suitable SQL query on my target database, which currently is hard-coded and described by this create table command that I have specified before. So now with that prompt, I can invoke the call LLM function. All right, and that takes as input the prompt, and now I should get an answer. Gonna print out that answer for the moment. And what I expect to find here is the SQL query that is semantically equivalent to the input question that was asked by the user. All right, So when invoking this code, I only need to provide one single argument, and that is the question that I want to translate into SQL. So here I have already selected a question. I'm asking how many customers do we have? So that should translate into a fairly simple SQL queries on my customers table. Let's see whether the language model can figure that out. So I'm gonna run the code that I have written so far. And after a couple of seconds, the language model responds as you see here. And it is actually quite a detailed reply. So it writes, to find out how many customers we have in the customers table, you can use the count function SQL. So that is correct. That is probably exactly the aggregation function I want to use in SQL to translate that question. And here the model gives me the translated SQL query for the question. And that is the query that you see here. And you might notice those special markers at the beginning and the end of the SQL query. So this marks up the code as SQL code. And if you were to use the web interface with OpenAI, which is powered by the same language model in the background, then you would actually see that code with a specialized markup, which makes it easy to, for instance, copy the corresponding code. All right, and here is even some final remarks here, which confirms that the query is indeed doing what we want it to do. It will return the number of customers in the customers table, assuming that each entry in the customers table, each row in the customers table indeed corresponds to one customer. And that is a totally reasonable assumption given the names of the table and of the columns that we find in that table. All right, so that is a correct reply generated by the model. And if you were using the web interface, and this is exactly the reply that you want, it contains not only the SQL query, but it also contains some additional explanations of the SQL query that makes it a little bit easier for you to trust it. But what we want to do in the following is to have a seamless natural language query interface, which allows you to ask questions, and then in the background the model translates those questions to queries. It executes those queries, and then it presents you directly with the result, with the answer to your question. So in order to execute those SQL queries directly, we're actually only interested in that part of the answers. In order to get to that part of the answer only, we probably have to do a little bit of additional post-processing of the answer generated by the language model in order to extract only the query that we can directly execute in a relational database management system. So in the following, I will use regular expressions in order to extract the part of the answer that we really care about. And in order to do that, I'm gonna use Python's re library, which contains lots of useful functionality for working with regular expressions. And here, after generating the answer by the language model, which now I'm gonna call a raw answer, I'm going to extract the part of the answer that I'm actually interested in, which is the query. And I'm going to use the find all function of the function, which requires me to specify a regular expression pattern that I want to search for. And if you look at the query and the associated markers at the beginning and the end of the query, what I probably want to do here is to search for a pattern that starts with those three symbols followed by SQL, and in the end again we have those markers which indicate the end of the SQL query. Now in between, of course, I have some additional text, which is the SQL query that I actually care about. So here I'm going to represent it by a dot followed by a star, which means I have an arbitrary number of repetitions for arbitrary symbols, in order to make sure that a dot can represent arbitrary symbols, including new lines, because you see that the query here is actually it is written in 2 lines. And I mean, if I have longer queries, it's actually recommended to format them by introducing a couple of new lines, line breaks in between. So in order to make sure that the dot can also represent the new line, I'm gonna use the dot all flag, which means that the dot can represent arbitrary characters and also a new line symbols. And here the string that I want to search for that pattern, that is of course the raw answer generated by the language model over here. And this should return me a list with all matches for this pattern within parentheses here. Typically I should only find one single query in the reply of the language model, but just in case there are multiple entries, I'm just gonna go for the first query that the language model returns, and hopefully it will return some queries, because otherwise this part here would throw an error. Now in the end, I'm just gonna print out the query, and hopefully it is just the SQL part that I'm interested in. Let's try that out using the same input query as before. So here again, I have the question, how many customers do we have? And that should translate into the SQL query that you see here. Let's see whether we can extract just the part that we care about most. And indeed, here we have only the SQL query extracted from the input. So far, we have assumed that we have to specify the structure of our data by hand. But of course, that's not very convenient, because if you want to use a new database with different tables and different columns and so on, then you have to enter this description for all of those tables and columns and perhaps additional constraints by hand. And of course, doing that is not very convenient. So instead of doing that, maybe we can make the code extract the structure of the data automatically, assuming that the data is stored in a relational database management system. Now, in the following, I will assume that the data is stored in an SQLite database. SQLite, that's a very popular relational database management system. It's very quick to install, and it has a couple of other features and advantages. So this is what we're going to use in the following. And in Python, you can easily use SQLite by importing the SQLite 3 library in this case. So that's what I'm going to use in the following. Now, I will assume that users provide as input not only a question about the data, but also the path of the relational database file. So here I'm going to expand the input arguments by adding a first argument here, the database path argument of type string, and the help is going to be, this is the path to SQLite data. So this is a file on hard disk which contains the data for all the tables that I am interested in. All right. And now, given that data on disk, I can automatically extract the structure of the data using the SQLite software. So I'm going to write a dedicated function for that. That is the extract the structure function, and as input it takes the path to an SQLite database file. So here I'm going to write a little bit of documentation. So here what this is going to do essentially is it's going to extract automatically the create table statements that were used in order to create all the tables in that database. And as input, it's going to take the path to the SQLite database. The output is going to be the create table statements from that database. Now, in order to access the structure of that SQLite database, I first of all have to create a connection to that database. And I'm going to do this as follows. I'm going to write SQLite3.connect. That is the function that creates a connection. And as input parameter, that function is going to take the path to the SQLite database file. All right. So now that I have the connection, I can create a cursor object which I will use in order to execute queries in that database. And in order to get the structure of the database, I can execute a query on some specialized data structures which can return me the statements that have been used in order to create the tables in the current database. So here I'm going to access the cursor a function, creating a cursor that I can now use in order to execute queries using the execute function. Now in this case, I want to write the following query in order to access the structure of the database. I'm gonna retrieve the SQL column from the SQLite master table. That's a specialized table which contains information about the database, and specifically I'm interested in information about tables in that database. So here I'm gonna restrict my scope of the query to elements of type a table. Now after executing the query, I can access the result of the query execution using the cursor object again. The rows of my query result, which also is represented as a table. So it has rows, and here we can access the rows of my query result by writing cursor.fetchAll. And those rows might have each multiple fields. In this case, actually, I only retrieve data for one single column, the SQL column, which contains the SQL statements that have been used in order to create the table structure in that database. So here, in order to get the table cells, I'm just gonna iterate over the rows, and for each row, I'm gonna access the first and actually only elements. So here, that should give me all the table cells that I am interested in. And now ultimately I want to return a text string that contains information about all the tables in this database. So here I'm just going to return the join of all of those table cells, which contains all the information about the structure of the database that I care about. Now that I have defined a function for automatically extracting the structure of a given SQLite database, I definitely want to invoke it here at the beginning of my code, probably in order to extract that structure. So here I now assume that users provide me with a path that leads to the database file containing the data that I'm interested in, and I can use the extract structure function in order to extract the corresponding structure. So here I'm going to provide as input parameter the path that users have specified as input to my program. Now, if I have the structure of the database, then clearly I have to integrate that structure into the prompt. So far in the create prompt function, I have assumed that the structure of the database is hard-coded, but of course now that doesn't apply anymore. So probably I want to add a new parameter in the create prompt function, which contains the structure of the database. So here I'm gonna add a parameter database structure to the create a prompt function. I'm gonna add some documentation for that parameter. So this is a string that describes the structure of the database. And now here previously I had hard-coded the text that describes the data structure. Now I don't want to do that anymore. So instead I'm gonna replace this as string by the input parameter database structure. And that's actually everything that I need to change in the create prompt function. It now takes the structure of the database as input and adds that to the prompt, which will be sent to the language model for text to SQL translation. Now I've changed the parameters of the create prompt function. I also have to change the corresponding invocation by specifying the structure of the database as input. So here we have the create prompt function using the database structure and using the input question by users. Now, in order to try that out, I first of all need an SQLite database file. I have prepared an SQLite database file which contains information about video games and about the associated sales number. So we are going to specify this database as input parameter, and it is located in the data repository. The database is called games.db. Now we cannot ask about customers anymore because there's no information about customers in that database, but the database has a lot of information about video games. So maybe the first question that we can ask to that database is how many video games are stored in a database. All right. So now we have the path to the database and we have a question that we want to translate into an SQL query. Let's see what it does. All right. And so here that looks perfectly reasonable. It is translating the input question into an SQL query, again a count query, which counts the number of rows in a table called games. Now I've actually not really said anything about the structure of that database, but we can simply print out the complete prompt that I am generating here, which also contains some information about the structure of the database. So now I'm gonna print out the prompt, and perhaps I'm gonna separate the prompt from the generated query. So here we're gonna first print out the prompt, and then later I'm gonna print out the corresponding query. All right, so let's execute it again. This time we're gonna see the prompt that the system generates and sends to the large language model. And here you see the prompt. So now this database structure has been filled with the structure that was automatically extracted from the input database. And you see indeed this is a table named games. And here you see the names of the columns and the associated column types. The names of the columns, they are quite informative, which is necessary in order to translate questions into associated queries. So here, based on the column names, you can essentially imagine what is the semantics of those columns. And the large language model is essentially doing the same thing when translating the questions into queries. So here, for instance, we have the name of the games, we have the platform on which they were released, and the year of the release, the publisher, and here you have the corresponding sales counts in different areas of the world. And given that definition of the table, the translation of the question, how many video games do I have stored into the query, so that count star as total games from games, that seems like a very reasonable translation, which probably accurately reflects the semantics of my input question. Now for the moment we are translating questions into natural language queries, but then once we have that SQL query, we still have to enter it in the database management system in order to get the query result, and doing that by hand is of course a little bit inconvenient. So it would be great actually if the system could just do that automatically and directly execute the query that our question translates to, and then show us directly the query results. In the following, I'm gonna expand the current code in order to automatically process those queries as well. So here I'm gonna introduce a function process query, which takes as input first of all the path to the database file, because this is where the data on which the query is processed is stored. Then of course the second parameter, that is gonna be the SQL query that we want to process. So let me add a little bit of documentation here. So here this function processes the input query on the SQLite database. And the arguments, that is first of all the path to the SQLite database, and the query, that is the SQL query that we want to process. Now what it returns is the result of that query as a result, a string. So yeah, that returns the query result as a string, so I can directly print that out. Now, first of all, in order to access the SQLite database, I have to create a connection again, which I have already done before, in order to extract the structure of that database. So here again, I'm gonna use the connect function of SQLite, using the path to the database file as input. Now that gives me a connection, which again I can use in order to create a cursor object, which then can be used in order to execute queries. So let me again create a cursor object using the connection.cursor function. And now with that cursor, I can use the execute function in order to execute the query that is provided as input. Now, in order to obtain the result to that query, I'm gonna again use the cursor.fetchAll function, which gives me the table rows. And now I'm simply gonna transform those rows into strings. So here I'm gonna just apply the string function for each row, and then the result of that function, that's gonna be the join of all of those rows, adding new line, adding line breaks between those different rows. All right, so now we have a function that we can use in order to process queries. I'm immediately gonna use this function in order to process the queries into which the system translates my input questions. So the result is going to be the result of the process query function, which uses as input the database path and the query that I have obtained here. And now I'm going to print out the result. All right, and now let's see whether the system can indeed process the queries directly that I'm translating the input questions to. All right, so here we see first of all the prompt. This is what the system sends to the language model, and then the language model answers by a translation of the input question into an SQL query. And here the result, that is the number of rows in the games table, which corresponds to the number of games that are indeed stored in the database. Now we're gonna take one more final step in order to make this interface more convenient to use, because when analyzing data, that's typically an iterative process. You ask a question about the data, you see the result, and that might trigger a new question that you also want to get answered based on the data. So in order to support that, we're gonna create a loop in which users can repeatedly ask new questions, then the system translates them into SQL queries, processes those queries, and shows the results to users. And then in the next iteration, the user can again ask a new question about the data, and again the system will show the corresponding result until the user enters a quit. In that case, the program terminates. So that means that first of all, the input parameters to the code here change, because I don't need to specify one single question as input anymore, but instead we will allow users to iteratively enter new questions. So I still need to extract the structure of that input database, so the remaining input parameter, that is simply the path to the input data about which I want to ask questions. So here I'm extracting the structure of that data. Now here gonna create an endless loop, but we're gonna also add a break statement so that if users enter quit, then indeed the program terminates. So here I'm gonna take the question as input from the user, and here I'm gonna use the question simply gonna inspire users to enter a question, and then in the following I'm gonna create a prompt based on that question. Then I'm gonna send that prompt to the language model and extract the SQL query, and finally I'm gonna generate the corresponding query result by executing the query and then printing out the result. Now we should still make sure that users can leave the loop if the question is equal to the command quit. In that case, I'm gonna break from here. All right, and now there should be an iterative natural language query interface which enables users to repeatedly ask questions about the same database until they are satisfied, then they enter quit, and then the program terminates. So let's see whether that works. Now, first of all, in order to use that, I have to delete the second command line argument. So instead of that, I only have the path to the database. So let's actually execute that. And here it first of all asks me to enter my first question. And that's where we see whether it still works. I want to know how many games are stored in the database. Now here the system generates the query, as you can see, and it provides me with a result. And now I can immediately enter a new question. And perhaps I want to know which game had most sales in the European Union. And after processing the query, we find out that this is it's a sports games by Nintendo. Or on the other side, maybe I want to find out what is the number of games that were published for each genre of games, such as action or strategy. So I'm asking it to break down the number of games by the type of game, and as you see here, it does that. This result looks reasonable. The corresponding SQL query also seems correct, and now I know like how many games were created for each category of games. So this is interesting. It seems to work. I can enter quit in order to terminate the code. And now with a few lines of Python code, we have indeed generated a simple natural language query interface that takes natural language questions, translates them into SQL queries using large language models, and then processes those queries and shows the results to you. And that's it. So now we have used the same simple Python API in order to analyze various different types of data, including text data, data tables, images, and sound files using large language models such as OpenAI's GPT-4 Omni model. So I hope you enjoyed this tutorial, and if you did, make sure to check out my website. You will find more materials, more tutorials on that website about the same topic, as well as the code samples that we have written in this tutorial.